All. My name is Manoranjan Oja, Assistant Professor, Department of Basic Science, Chemistry, SR University. Today topic is applications and material selections. So we'll discuss here that for which purpose we are using for different materials and what are the criteria for that one. We'll discuss in this topic. So we discussed that optical properties and dielectric properties of the materials. Now because this is very crucial for the modern science or engineering and technology, so here in this section so we'll discuss that applications of these materials, where it is application is there, and the how we can select the materials for which purpose we are going to use it. So it is very essential criteria that how we can select the materials for our uses or in applications. So these properties determine the how materials interact with the light. That is the electronic. This is the optical properties, that interactions of the materials with the light. That is, we are discussing the optical properties, and the electric field as well for dielectric substance. That how the materials is also interacting with the electric field. So two types of the property we are discussing. That is called the optical properties and the dielectric properties. So because this will enable us to wide range of applications. If you know these two properties, that interactions of the materials with light and interactions of the materials with electric field, so we can get the wide range of applications of in the field of electronics or for communications or energy systems and medical devices, consumer products in all way. So because these materials is being used, optical materials or dielectric materials in these applications. The selections of the appropriate materials based on their optical and dielectric characteristics is essential to achieve the efficient performance and durability and cost effectiveness in practical applications. So after the knowing the properties of the materials, then we can select which is efficient, means performance is very good, and also durability, how long we can use it, long lasting capability of the materials, and the cost effectiveness in the practical applications. That is means how easily we can make it, that processing cost for this material will be less. So this we'll discuss in these sections. First we'll discuss that applications in optical materials. So where the uses of the optical materials in that one we'll discuss first. So there is one called optoelectronics and photonics. This is the section the material is used. The materials with control optical properties are essential in optoelectronic devices. So and this is for optoelectronic devices which this material is control with has a control optical properties, so that can be used in these sections, such as for light emitting diodes and laser diodes or photo detectors and solar cells. So here that if particular energy gap or band gap of the material it does not meet into the criteria, then we cannot get this kind of properties of laser diodes or light emitting diodes or photo detector or solar cell. So for example, we need one compound or one material for the solar cell, that it can be used for absorbing the radiations or light from the solar light. So electronic transitions can take place. It will create the holes. Then electron will migrate into the higher energy state, and then solar cell this current can be generated. So if that band gap does not match with that in the this region of the visible light or solar light region, then we cannot get this effect. So that's why we need very control optical properties of the materials for its applications in different field. For example, let's say semiconductors, silicon or gallium arsenide and gallium nitride will be selected based on their band gap energy. So if this band gap does not meet, then we cannot use for the in different purposes where we are going to use it. So light absorption and and another thing is light absorption and emission efficiency. Let's say what are the materials is absorbing light. After the absorbing light, how much energy it is taking, or we are providing for outside how much energy to absorb the light and to go to the ground state to the energy state. Then emissions are how much energy we are getting. So that is, if we are getting similar energy, then we can tell that efficiency is high, so we are not losing much more energy. So for that one we need some compound which is having higher efficiency and is suitable, that band gap is suitable for our uses. That materials can be selected on that basis. Now, optical communication systems, the fiber optics communications, the material must exhibit high transparency. So if materials optical behavior means transparency will be much more higher, otherwise we can't use for this purpose. And low optical losses, so means after passing the light through the materials, this opticals should not, light should not, intensity does not lose. So means we need higher transparency, means optical, it should not lose the low optical loss should be there, so it should not lose much more the intensity of the light. So this is the primary criteria for optical communication systems. Silica based glass fibers are widely used for this purpose due to their low attenuation and high mechanical strength and excellent transparency, so transmissions performance over the long distances. So that's why it is used, the silica based glass fiber is used for the optical communications systems. It's called lenses for displays and for imaging system. For this, for applications for making the lens or display and for imaging systems. Materials for the lenses, for camera system or display panels and optical sensors are chosen for this for the materials. And for that one, you should have their refractive index and clarity and the resistance to the optical distortions. If this property it is matching, that can be used for in this section, that is called lens or displays and imaging systems. So this can be systems can be in this can materials can be used. So for this one, optical glasses or polymers or crystallines materials such as quartz are commonly used for these purposes, that is for lens or display and imaging systems. These are has been used. Medical and scientific instruments. So optical materials which are used for endoscope or microscope, laser surgical tools and diagnostics equipment, biocompatibility, optical purity and stability under radiations or heat are crucial for the factors. So here is much more important because we are using it for medical purposes and scientific instruments. These are very sophisticated instruments. So optical purity should be much more higher and stability under the radiations or the heat should be critical. Here would be a critical factor when we are using this one for the medicals or scientific instruments. So dielectric, so previously we discussed this one, the optical properties. Now we are going to discuss the dielectric properties of the material and their applications. Dielectric properties means to describe a material's ability to store or dissipate the electrical energy when subject to an electric field. So what dielectric properties we are discussing here, that a materials when you will place in the electric field, in the presence of the electric field, the materials can store the electrical energy. So that materials is called the dielectric properties, dielectric materials. So in the present we need the electric field to store the charges, so like a capacitor or something that is also store the electrical energy or in the presence of the electric field. So important dielectric parameters include dielectric constant, that permittivity, and the dielectric loss and polarizations and breakdown strength. So this dielectric losses means We are using electric field for the molecules to store the energy, but in that electric field we are applying, that can be used for multiple purposes as well, not only for the energy storage. It may be used for the movement, it can be used for the uh, generating the heat. So then because of this process we will lose some energy, so that is called dielectric losses is happening there. So for dielectric compound where you are going to use it, so dielectric losses should be less for those kind of a compound when it is used for a good dielectric substances. This is the one property. Polarization's property is that, so when we are applying the magnetic field, sorry, electric field into the system, so the dipole moment of the molecules inside the unit cell, there will be a permanent dipole moment will be created. Polarizations, that is called the polarizations. If polarization is not created, it means it is not interacting with the electric field. So polarization should take place in the presence of the electric field in the molecules in the dielectric substance. And the breakdown strength, so means at which conditions that molecules does not behave or it is degrading, that is the breakdown the strength of the compounds. So these properties of these parameters can be give the importance or can be analyzed when we are going to use the material in different applications. So here one, as we discussed earlier, it's called capacitor and energy storage devices. So dielectric materials are the central to a capacitor design. So high dielectric constant materials such as ceramic oxides. So these materials enable greater charge storage in small volumes. So in capacitor, what we do, that we will take the two conductors in between we keep the dielectric substance. Then we applied the potential or we applied the electric field between two conductor. Then due to the presence of the electrical field between two conductor, that inside dielectric materials, what will do, it will store the charges. So that is called capacitors. So it is storing the charges because there is electric field is applied between two conductors. So we need to use some materials which can store much more energy in the dielectric substance. So this example is barium titanate or titanium dioxide. This is the used generally because it can store much more higher energy in a small volume, right? So microelectronics and integrated circuit. In semiconductor devices, dielectric materials act as an insulating layer. So in the semiconductor means the energy gap between energy or band gap from the valence band to conduction band is less than 3 electron volt, but the insulator materials is more than that of 3 electron volt. So in this in semiconductor devices, this dielectric materials which is in insulator in nature, that is acts as a insulating layer, get dielectrics and interlayer insulator. So it is used as a insulator in the conducting semiconductor devices. Materials such as silicon dioxide SiO2 and high K dielectrics are selected for their thermal stability and low leakage current. Low leakage current means when we are applying the electric field, if charge will move inside the compound, then there will be a passes of the current. If passes of the current will happen, then we cannot get the good result from the devices. So we need to block the current. There should be very less or no electric current or movement of the ions should takes place. So when it is takes place, then we consider some current, it is leakage happening, leakage current takes place. So we need as much as low for this compound. So that's why this compound is chosen in such a way that there should be very low leakage current and thermal stability, which heating that compound structural degradation should not happen. So structural thermal stability of the compound should be there. Now for radio frequency and microwave devices. Radio frequency and microwave devices. Dielectric materials are used in antennas or resonators or wave guided or substrates as well. Low dielectric losses and stable dielectric constant over a wide frequency range are the key requirement of for the high frequency communication system. So what we need? We need that low dielectric loss. The compound should be have the properties of a low dielectric constant. So means when we apply the electric field, then there will be orientation of the dipole for the polarizations. But that electric field we are using, that electric field will be used in different purposes as well. So not only for the creating the electric field or polarizations, it also has been used for the heating purpose or some kind of energy loss will be there. So this loss should be less, so efficiency should be more, and also stable dielectric constant over a wide frequency range. So when we are changing the frequency of the electric field, then the dielectric constant should not change, means stable, there will be stable dielectric constant over a wide range of frequency. For this, when it is qualified this properties, then that can be used for high frequency communication systems. Right. So we'll discuss the electrical insulator and power systems. In transformers or cables and high voltage equipment. So for high voltage equipment, dielectric materials provide the insulators and the prevent electrical breakdown. So means when the high voltage equipment will be there, so then the current can be passed. So we need very strong insulator properties that it will block the passes of the charges. So for that we need a insulator, very high dielectric materials for the insulation purposes. So for that one, ceramic or polymer or composite materials are selected for this insulation strength, thermal resistance and longevity. For that purpose, we are using this kind of a compound. Criteria for material selections. Now, these are the properties when you are going to use in different sections or different applications. Then what is the material properties should be? For let's say selecting materials for the optical and dielectric applications involve balancing that you need the performance balance, environmental resistance, that it should not degrade over the time, means stability will be much more, so longer durability will be there, and manufacturability means how easy we can make it, what is the cost of the process or how easy the process is, and cost of the process. So easy, how to make it easy, large scale, then what is the cost for making this compound, then it should be a longer stability, so stability should be very high, less environmental resistance means degradation should be less, and also performance should be more. So these are the criteria when you are choosing the materials for our applications. So now optical material selections, what is the criteria we see? This is called refractive index, determines the light bending and focusing the ability. So refraction means here that when this light is passes through a medium, then depending the wavelength, the light bend, that is called the refractive index. So let's say this is one medium. So then some light is coming here, then when it's pass through, then it will bend, then it will go. So because of speed is changing, so that's why light bend, when it is going through the different kind of a medium, this process is called refractive index. And this one you can see in the when it is practically you can observe it, that when you are putting a straw in the glass of water, that when light is coming from outside from the air, it is going through the water, then is light bending happened. So this is the determine the light bending ability, bending and the focusing ability of the material. So this parameter we can consider, that is called refractive index. Then transparency and absorptions. The critical for the lenses, because it will for the lens purpose of fibers and windows. So we need very transparent compound to use for the lenses. And what is the light it absorbs? That is also, so absorption, how much it is absorbed, that also be essential criteria. So for lenses, so when we are going to use in the compound for lenses or fibers or window, so for that one we can consider this parameter called transparency and also absorptions. Then optical band gap. This is important for light emissions and detections, because the emissions of the light will be happen from the electronic transition from the conduction band to the valence band. So this means ground state to the excited state. This energy difference between is called the band gap. So band gap is very important when light emissions process is the measure what we are looking for to for its applications. So then we should be well known about the optical band gap of the materials. So for when we are going to use for light emissions property. Now, this thermal and chemical stability. So means this materials, let's say we have designed some materials which having very efficiency it works, but how long it can sustain. So in the environment, these materials can degrade and then can interact with the moisture or some other chemicals in the atmospheres, and also for thermal regions that my compound can degrade it. So this compound, how it is withstand or stability is there in the thermal way or in chemically. So that is very crucial for its stability or longevity of the materials. So thermal and chemical stability cannot be ignored for the material selections. Dielectric material selections will, if you will consider, then dielectric constant, how much dielectric constant affects the charge storage, because it affects the charge storage, how much charge storage can be happen or can be takes place, or signal propagations, it can be determined by the charge dielectric constant. So if we are looking for using the in capacitor for, let's say, for charge storage devices purpose, then for that one we need to know that what is the dielectric constant of the materials. Higher the dielectric constant of the materials, so it can store much more higher energy, or charge storage can take place higher in rate. So dielectric losses, this let's say we are applying the electric field, then this we are not able to store all the energies there, so some kind of a losses will be there. So that's what it is very essential to know that dielectric losses for that compound. If losses is much more higher, then means we can't use this, is not a suitable materials, because it is we are providing the energy, it is using for other purposes as well. So that's why dielectric losses should be considered when you are choosing a materials. And that's why if dielectric losses is more, then our efficiency will be less. So we need to make sure the compound has a lower losses, so that we can get the higher efficiency of the material. So efficiency is higher means is the best choice for the applications. Breakdown strength. So in background strength means for let's say for taking the example of the capacitor. So at how much electric field we can give, the maximum field we can give this to store the charges. If after a certain limit the material cannot withstand in this much of electric field, then this degradations happen in the compound. So we cannot use beyond a limit. So this limit for a material speed is high, then you can use for the highest possible way. So this breakdown strength should be higher for the any compound when you are using for it. So that's what the background strength need to be understand, or it should be checked and should be high for a compounds. Temperature and frequency stability. And frequency stability means the electric field we are using. Now, what is the electric field we are using? What is the frequency? If it is sustained for a different frequency, then it can be used. It is a high usable property will be there. If it is degrade with a different frequency or behave differently in different frequency, then may not be suitable for our applications. So and also with increasing the temperatures, these properties of the optical or the dielectric properties of the also material can change. So that's what temperature, which temperature it can act, and how much the temperature range we can go for the stability of the materials, that cannot to be understand. So materials commonly used for optical fibers. For optical fibers, the general materials is used is called silica glass. That is for optical fibers. For LEDs and lasers, so this is gallium nitride, gallium arsenide, or this is indium phosphorus. This compound has been used. And for capacitor, that we are using the dielectric substance inside between two conductor. Normally it is used for barium titanium oxide or barium titanate, or also some different kind of a ceramic composite also has been used in the capacitors. Right, so for IC dielectrics, so that is for SiO2 or hafnium oxide also has been used. And for display panel, the liquid crystals or transparent polymer has been used for the display panels. So here we will discuss that what is the emerging trend and advanced materials. So emerging trends means in this modern research, what is the now trend it is coming, that what kind of the materials can be used for the advanced means we can make it for our advanced applications. So this is focused on the nanomaterials, metamaterials and hybrid composite to enhance the optical and dielectrics performances. Nanometers, the surface area of the nanometers is always will be very high compared to the normal materials. So that's why this activity is surface area will be high, and its activity also it will be high. So that's why for every applications people used to talk about the for nanometers, from the using in the energy storage device, or maybe in different process, maybe drugs delivery, or maybe in other catalyst properties. So everywhere you will see the nanomaterials, use of the nanomaterials, because his activity is much more higher. So that's why it is has been used, and we can get a different kind of advanced properties for the nanomaterials. For photonic crystals for light controlling, for example, photonic crystals is used, that is for the controlling the lights. Flexible polymers dielectrics for the wearable electronics. So wearable electron, small gadgeted for electronics. So flexible polymer dielectrics can be used. Flexible means you can just press it or bend it in different orientations. It won't break. So it is flexible polymer that can be used as a wearable electronics. And transparent conductive oxides. This is used for touchscreen and solar cell. This transparent conductive oxides TCO. So in this conductive oxides, what it can, the light can pass, so that's why it can be used for the solar cell applications. These advantages materials is enable mean miniaturizations and higher efficiency and multifunctional devices. So what we are looking for it is that one materials we are preparing for it, that if it is having multifunctional properties, means that can be used in a different purpose, that is very much suitable, and the efficiency of the materials should be very much high. So that's how we will select the materials. Conclusion will be what we are discussing in these sections, that we are discussing this optical and electrical properties the materials having, two way what is the applications of these materials, and what the properties should have the materials to use in that application. So what are the criteria, or what is the parameters it should have for using those materials in the optical for different applications, or the dielectric properties with different applications. This one we have discussed here. The successful material selections depends on understanding the interactions between the materials with light, that is for optical discussion we have done, and with the electric field, that is we are discussing that is the electric properties of the material, as well as the operational requirement of the applications, means where we want to use this, for whether we are using for energy storage, for capacitor, or for the lens, for other purposes, or optic fibers, So which way we want to use it, according to it, this properties can be or parameter can be decided for the uses. And continuous advancement in the material science are expanding the performance of limits of the optical and dielectric materials, leading to more efficient, compact, and innovative devices. So we can use the materials for the, and we can modify the materials for our advanced uses purposes, so to get the multi-dimensionality or multi-functions of the compounds. So that's how we can choose the materials. So these are the parts. So we have discussed that advances continuous, we need to be modified the materials property, or alter or modify the chemical structures, compound structures, to get the advancement of property, and which can be used in now for advanced science for its applications. So this we have discussed in these sections. Okay, we'll stop here. We'll see in the next class.